Go ahead.
Okay, sounds great. Thanks for the intro, Amy. Um, okay, as Amy mentioned, I'm part of a company called Mathworks. We're a sponsor of RoboCup and we're a partner. And what we've prepared here for you today is we're going to introduce ourselves, let you know what we do. We make software. And two, since a lot of the RoboCup Junior leagues use Lego robots, we are going to do a brief introduction and teach you how to program Lego robots for the competition um, in general, so that participants that are interested can get up and running pretty quick. Um, my colleague Nobu Ijima and I put together this workshop for you guys. We hope you will like it. And if you have any questions, feel free to put them in the chat. I will be monitoring that, or you can unmute yourselves and ask them if whichever one you feel more comfortable doing. Um, and with that, we will go ahead and get started. So by the end of this webinar or workshop, we are going to teach you how to program the Lego EV3 controller, robot controller, and you're going to be able to blink the LEDs that are on the brain or the Lego computer itself. And you'll might also be able to upload a line tracking algorithm. So trace a line using a robot. Um, we will provide some code. The code is available. Everything is available online, and you can always reach out back to us with any questions. If you're wondering who we are, we are a pretty big company that is very invested in education. Um, Mathworks, we sponsor and support over 5.6 million students and over 1,700 universities worldwide. Um, all of the top ranked universities use our products for teaching, and most people have in these universities have unlimited access to our tools. And we're also a software company that is constantly hiring. So if there's any interesting prospects, we have a lot of job opportunities and career opportunities. And we are also very involved in research, in active scientific and engineering research. So our tools are widely adopted throughout the technical industry. And if you're wondering what type of industries that is, it's anywhere from cars, airplanes, to space exploration, rockets, mechatronics, your phones, consumer goods, robotics, which is what we're going to talk about today, and energy production as well. So our products are pretty generic, and they are also go pretty deep into some of the applications that you see here. So we're highly invested in moving technology forward. This is a brief video of how we sponsor student competitions like RoboCup. So a lot of students worldwide use our products to participate and win at competitions. This is actually a video of RoboCup right here. Many of the teams in RoboCup are already using our products to design and program their robots. And in other competitions, like for cars and airplanes and different type of student competitions, it's also widely used. We have mainly two big family of products, MATLAB, which you might have heard of, which is our most popular sort of product. And it's a technical computing environment, so it's like an integrated programming environment. You can do numeric computation, generic programming, visualizations, data analytics. And then we have a lot of these specific libraries for special things like signal processing, machine learning, deep learning, optimization, math, um, pretty much anything you can think of that is scientific or technical. And then there's a product that might be a little bit less familiar, which is Simulink, which is our simulation environment, or what we call simulation and modeling environment. And this is an environment where you can put together models of physical things, whether you want to do it from the basics, equations, or you want to put together actual parts and components of a system in order to simulate something and help your design process. You can also use this to generate code automatically. Um, so you can create the simulation, program your robot in the simulation, and then move that algorithm into your real world robot. Okay, so here's just a couple of examples that might be exciting for the robotics audience. So you can obviously do path planning, so things like figuring out the best path through a maze or through a generic environment, image processing, things like color thresholding, object detection, object classification, anything related to processing images, object and obstacle avoidance. We have a lot of tools for processing 3D point clouds and in general LiDAR information and then how to avoid things. Um, line tracing or line tracking. We have a lot of support for hardware and sensors to be able to develop this type of algorithms. And then phase recognition is more of like a deep learning related example. We also have a lot of tools for simulating robots and in specific tasks like manipulation. Okay, hang on. Sorry. So in here, what we have is an example. This is a little race car that we use as a demonstration that is all programmed completely in our tools. So as you can see, you can perform mapping of an environment, you can select target areas, you can simulate the dynamics of the platform that it's operating on, like in this case, that race car. You can process the sensors. So in this case, it's processing a point cloud, camera information, LiDAR information, so distance sensor information. And it's automatically delivering a book, in this case, in between two offices here on our campus. But it's just an example of the things that you can achieve with the tools that we already provide. So if you're trying to design your own robot, we're going to be able to provide with a lot of different software libraries to make that be a little bit quicker. Okay, so today we're going to be talking specifically about how to apply all of this to Lego. So if any of you are not familiar with Lego, feel free to ask questions. And if you are, then maybe this is going to be a little bit of a repetition. But Legos can be set up over a network, over a Wi-Fi network. Um, so the only thing you would need to program a Lego from our tools would be a USB cable. So I have one right here, just a demonstration. This is just a USB, regular USB to mini USB. So, and we have a robot over here, which is connected just through a USB cable. And we'll also show the robot in a little bit. But all you need is a USB cable and you'll be able to program your robot. Now, on top of that, we have capabilities for actively debugging those robots and creating user interfaces, which is very exciting and very useful. If you want to take advantage of those, then you will want to set up your robot through a network. And then there's a couple of options there. If you are already a Lego user and you might have one of these, this is a Wi-Fi card or a Wi-Fi dongle that gets connected to the USB port on the Lego. Then you can use that connected to your Lego robot and then connected to the Wi-Fi network that your computer, your programming computer is connected to. And then the other option is to use one of these USB to Ethernet adapters. There's a couple of supported ones for the Lego. They look like this, which is what I'm going to be using today. But bear in mind, you can also do it over Wi-Fi. And that way you'll be able to debug your robot. And the robot we're going to be working with today looks something like this. It just has two motors, a right and a left wheel. And today we're only working with the color sensor. But you can also add other sensors and build your own robots. Like I said, I'll be using the wired connection through Ethernet. And if you're doing that approach, you're going to want to connect both your computer and the Lego to a router, to the same router, so that they're both connected to the same network. And if you're using the USB adapter, you're going to go through the setup screens on your Lego brain computer. device, and then just connect to the appropriate Wi-Fi. And it will look something like this. You'll go to the settings, um, and then select Wi-Fi. So I'll highlight this briefly. Um, you go to the settings tabs, select Wi-Fi, turn that on, and then go to connections. And then after that, you can find your IP address by going to brick info and scrolling down until you find your IP address, which is just the address or the identifying number of your robot in the network. Okay. So I'm gonna take a break right there. So if there's any questions, please let me know. Put them in the chat. Otherwise, we will continue. Is everybody all right? So we understand what we need. And you guys can follow all of this because it's going to be recorded afterwards with your own robots. So you can always come back and ask us more questions. Okay. So there is a procedure for verifying that you've connected the Lego to MATLAB. You can type in, actually, what we'll do is we'll open up MATLAB so that you get a sense of what it looks like. And this is a little agenda of what we're going to achieve today. So we're going to show you some basic Simulink operations. Then we're going to show you how to add the specific library of blocks to program your robot. We're going to create a basic model or a program. We're going to configure the necessary parameters and upload. So after this, we're going to do everything in what's called MATLAB, which is the product that we create that we're going to use to program the robot. So I'm going to go ahead and change to that now. Okay. Guys, can you guys see my screen right now? Can someone help verify that you're seeing my MATLAB screen? Okay, great, a lot of thumbs up. So this is what MATLAB looks like. So whenever you open it up, you're gonna get this toolbar up here, which is similar to many other programs. And here you're gonna have what's called the working directory. And this just means the files that you're currently working on and the folder in which they are. And on the left, you have the current folder or your file explorer, much like you would have in your Windows Explorer. So you can see all the files that are available in that folder. You can open them. And then we have a couple of other things like the workspace. And if we change the layout in this case to default, and we'll see that in the middle, this is our command line where you see the command window with two sort of brackets there. And then if you type anything there, like for instance, u equals 1, you'll see that we've created a variable u equal to 1, and we can see it that it's on our workspace or it's available for us within this database that we just created called the workspace. For the purposes of programming this robot, what we're going to use is actually Simulink, which is our simulation and modeling platform, and it's this button right here. So you'll find it in the toolbar. It looks like a couple of blocks put together, blue and a red block, and it says Simulink. So we're going to click on that. And that's going to bring up the startup menu for Simulink. And in here in Simulink, you'll see that you can create a blank model or other options. We're just going to create a blank model for now. And we'll show you how to edit things in this program. Okay, so you can see it's like a blank canvas. So think of this as like a whiteboard where you will add different portions of your algorithm. In this case, I will open up this library browser up here. And we can see all the blocks that are available. I'm going to select commonly used blocks and just drag a couple that I'm familiar with. So I'll drag this relational operator. I'll grab a couple of constants. And then I will grab from sinks, I will grab a display. So as the name suggests, this is just a constant, so it's just a number. I'm going to copy this, and we're going to create two numbers. I will make this number a 4, and we will leave this one as 1. And we're going to try to identify for now as a very simple example whether 4 is greater than 1. So this is just a relational operator, so a logic operator. We'll select the right one. So let's say if it's greater than, we can see it change, and then we'll connect the output of that, which is the result, to this display right here. And the way, after you've sort of put together a couple of blocks and connected them with these lines, you can run it. So up here, you'll see a set of options in which one of them is just the run button. So I'll go ahead and run it. And we will see that, for instance, in this case, we run it and it tells us 4 is greater than 1. And this is what's called the Boolean. It's just telling us that this is true. It's 1, it's 0 or 1. And if we were to change this to a 6, for instance, then we should get a 0. So you can see in here that now 4 is not greater than 6, right? So this is how you put a basic Simulink model together. Do you guys have any questions about MATLAB, Simulink, how to put these models together, or maybe what they're used for before we continue?
You can use chat or you can speak up if you have any questions. No, I guess.
No questions. Okay, sounds good.
Oh, okay. Hold on. There's one question. It says, is MATLAB an interpreter or can you compile it too?
Great question. Thanks. So as it is working right now, so if you just run the simulation, or if you just like write code in this command line right here, it will be interpreted. So it's an interpreted language. But if you would like to compile it, you can do that. I will open the Simulink model here all the way. So hopefully you see a couple more things. So you will get more options up here in these tabs. So you can you can configure this model to generate and compile code. And what it will do is it will basically write up your whatever you described in this block diagram. It will write up the code for you in C++, and then you can compile it, or it will compile it for you, depending on how you configure it. And what we're going to do today is we're going to compile code for the Lego robot. Okay, so let me know if that answered questions. Maybe give us a thumbs up. Great, looks like that works. Is there any other questions about MATLAB or Simulink? Okay, we will continue. So now that you've seen Simulink, we're actually going to get into programming the Lego robot. And the way you do that is by getting access to the necessary, what are called drivers. So you need to be able to get in touch with the components within your robot. So you need a library called the Simulink support package for Lego Mindstorm's EV3 hardware. And as you can see in here, this is a lot more relatable to what we're trying to do, which is program this robot. So you'll see here blocks for getting the battery information or using the buttons. So I'll try to highlight a couple of these. For instance, using the buttons in the controller, using a color sensor, activating the lights, using the ultrasonic sensor. So there's a lot of different blocks that are specific to Lego. There's even a Pixie 2 vision sensor in case you're connecting that to your Lego robot as well. And what you would do in this case is you would just drag these blocks into your Simulink model, and then you will continue. One piece of advice that we're going to show you today, which makes it a lot easier so you don't have to configure the model. Normally, you would have to go here to modeling. So up here, and I will show this for reference. You go to modeling and model settings. And in there, you will let Simulink know that you would like to send your code to a Lego robot. So you go to hardware implementation here on the left, and please let me know if I'm going a little too quick. And you will see all of the available hardware in your computer. And in this case, you would select Lego Mindstorms EV3. Okay. And then you will notice that immediately our toolbar changed. And now on the top, we've got then this hardware tab that has a lot of different options for us to use. One of those options over here on the right is build, deploy, and start, which is also the equivalent of a program button or a build button in other IDEs. But we also have a lot more tools here, like this monitor and tune button, which we will talk about as well. Okay. For the purposes of getting started a little bit quicker, we will close this and show you how you get this library added to your MATLAB installation. So this is an add-on, what we call an add-on library. So just briefly, I will show you how to get that installed. You would go up here to your MATLAB toolbar, and there's a button called add-ons. You will click on that, and it will bring up a little add-on or library browser with a lot of different things that you can add to your MATLAB installation. And you can just type in there Lego, and it will search. So in here, you'll see all the available support. So this is Simulink support, and this is MATLAB support. So these are the libraries. So if you go and you click there, in this case, you can notice that mine says that it's already installed here in this corner. But if you haven't installed it yet, it'll just give you a button here that says install. And then you would just click that, and just basically like a regular installation of an additional program, you just say in the wizard, just say next, next, next. And then this will be installed. Any questions on that? Okay, great. So what I'm going to do now is try to create a model and send it to my Lego robot. So I just turned on my Lego robot, and we will build a model for it. So if you go to this startup page, I just click the Simulink button in MATLAB, and we scroll a little bit down, you'll see that there'll be a drop down for Simulink support package for Lego Mindstorms. I will open that up, and it gives me some templates that will make it easier for me. So it says basic model, external mode, algorithm. So I'll just click on create model. And I will expand that so that you guys can see it better. And it will give you the instructions of what you have to do in order to program your robot right here. Make sure you've added the Simulink library. Make sure you've added the necessary blocks. Make sure you've configured your model properly. And then finally, you just press that button once all of the configurations are done. The build, deploy, and start. Okay. So we'll just change the title on this. We'll say Blink Lego LED. And I will just delete this button because I don't plan on using it. The same for this display. We will go to our library browser, and we'll grab this light from here, status light. And this sort of colored boxes that you see here, they're just that's just what they are. They're just little colored sections put in there for you to organize your blocks when you're getting started. So in here, I'm adding an output. So this is a space to put like actuators and output, but you can also just delete those if you don't like them. Um, you can start with a blank canvas. Um, and in this particular case, I will double click. So after I've dragged this, if you're ever wondering how to use a block, so what information should be going into this block, you just double click on it and it will give you the information of the block and any parameters that you can change. In this case, it's telling us control the color and effect of the brick status light. The block input accepts these numbers, 0 through 6. And in this case, if we look in here, it says number 4, it's pulsing green. So we'll try to go for that. We'll try to make the light pulse green. So we'll send the number 4. So I'll just this is a little shortcut. If you just click and then you type on your keyboard the block you're looking for, it will search for it. And in this case, I will create a constant that is the number 4. And we will send that. Now I'm going to change really quick. Hopefully you guys can see my Lego robot here on the left. And we will go to hardware and select build, deploy, and start. You'll see here on the left a little menu that says code generation, and it says generating code templates completed. So I think you can see it now blinking there. So yeah, if you are looking at the Lego, you can see the LED blinking. So it uploaded that code in there, and it also here in the screen, you can see that it just showed us all the code that it generated in case we want to go in and like read it and take a look at. Amy, did you have a question?
No, just clapping because I could see it blinking. Can you actually show us how did you open the report? Sorry, I missed it.
How did I open what, Amy? Sorry.
Report, the report that you're showing.
Oh, the report. The report in
Mhm.
this case, because I use I'll just go ahead and change the camera real quick so that it's not as awkward. In this case, since we open a
Okay.
template, the report is automatically open.
Oh, okay.
Yeah, and you can change it. There's a lot of things you can change. So it's very good to get familiar with this sort of model settings here in the modeling tab, because you can change pretty much all of those behaviors from there. So if I go to model settings, I'll show you in case you have a model that doesn't open the code or the report. In here is where I showed you, you could select your hardware. And then if you go to code generation, you will see under code generation, I will highlight some of these. There is one that says report. So if you go there, there's 2 checkboxes and it says create code generation report and open the report automatically. Yep.
I see. Thank you.
And in general, that's a great question because there's lots of things that you can configure in here, both about the code generation in general, if you are more advanced and want to change some optimizations or things like that, you can do that in here. Okay. Do we have any questions so far? No questions. So I'm just gonna stop that program and the robot from running. What I'm going to do right now is delete some of the stuff that's here to clear up some room. Um, and show you a little bit of a cleaner sheet. And what we're going to do now is we're going to make those motors move. Um, so we'll do the same thing. You'll see in here that we have blocks for encoder, gyro. So we'll just find the one that says motor, which is this one. And we can try a couple of different things. In this case, I know that my motors, if we open the block one more time, it says how to use it. So in this case, it's telling us if we send it a number or a value of 100, that's full power forward. 0 means no power, and then negative 100 is full power in reverse. And then we select the port that we've connected it to in the Lego. In this case, I know that B and C are connected, but not the others. And what I'm going to do is put another constant in there. And I'm just going to throw in there a number of 30. And I am also going to add something called a scope here. So a scope is essentially like a plotter. So it will show you a signal. The reason it's called a scope is because the x-axis of the visualization is time, right? But we can open up that scope and it will show us that number with respect to time. And what we can then do is go to our hardware tab, and I will change the stop time. So because Simulink is a simulation environment, the biggest difference between a regular like programming or coding environment is that it's taking into account time. So there's a solver underneath that's going to help, propagate the results of something with respect to time. So in this case, we were running the simulation for 10 seconds. So if we were to upload this code to the robot, it will also run for 10 seconds. So we want it to run indefinitely, so we're going to change that to infinity. So INF. And instead of clicking the build and deploy button, I'm going to press this monitor and tune button right here. And now I am quickly going to change to my robot view to show you that we've used the Ethernet adapter that we talked about that looks something like this. And that is connected over here on the left through the USB port of my robot. What that's going to do is it's going to let us transfer information back into the environment itself. So it will act as a debugger, but it will act as an interactive debugger. So I will go ahead and press play and show you what that looks like. And there is a chance that we might have to configure a little bit more, which is a great opportunity to show you how to do that. So the code generated correctly, so we can see the report here with all of the necessary files that are being compiled. We'll just give it a second. So when you get an error in Simulink, and this is very useful, it will show it down here in what's called the diagnostic viewer. And this is very important for when you're programming in Simulink because you will run into errors and you will need to learn how to fix them. So for instance, in here, we will read what happened. It's telling me attempting to establish connection with the host name, so with my robot, and it couldn't connect to it. And I happen to already know why that is. So the IP address, we haven't set it properly. But it will look something like this. So then you can Google the error, or and then you will find an answer for it. So we'll go to hardware settings. And in external mode, you will see, we'll change this to 102, host target connection. And we will go ahead and try that again. Okay, looks like we're getting the same error. And probably the reason for that is because I am currently connected to Wi-Fi. So we're gonna have to let that go. One, I think we'll just not try that because you would have to like make sure that your network connections are set up properly. So I will check really quick through my command line. And in the brick, we already showed you how to check the IP address. So I'm gonna check quick. Okay, yeah, see what the issue is. So sometimes you might have to rearrange your network settings. Um, I will try to do that real quick for the interest of the webinar, but otherwise we will continue. Okay, we'll try that one more time. Okay, so yeah, that's not gonna work while I'm teaching the webinar because I'm connected to the internet. But normally what would happen is that it will start running and then you will be able to see all of the information here in the scope. We have a little video of that, and we will go through that. Um, for now, we will show you how to get the motor to move. So I will just click build instead of monitor, and we should be able to see the robot moving. Okay. So you can see the wheel moving, and that's the motor in port B that we've programmed. I'll go ahead and stop it. And if we would like to program both motors, we just copy the block and change the port. And in this case, I will just send the same value to both of them. I will move the robot so you can see it. And we will build it again. Okay. And I will go ahead and stop it. Okay. So let's take a look at what we've learned so far. Um, we've already gone through a lot of these. We show you how to install all of the different things, and we show you how to blink an LED. Here's an example of what it looks like when you're able to connect to the device, in this case, the Lego or an Arduino. So you can also do this with different pieces of hardware, like an Arduino or a Raspberry Pi, depending on what you're interested in programming. So in here, you can see the little knob is available. It's what's called a dashboard block. You can see a scope on the right, and you can see how when you move the knob, you can turn that light on and off, both in the Arduino and it will show you what it's doing in the Simulink environment itself. So that's the same ability, the same functionality that you will get with your Lego robot. Just make sure that you're not you have all your network adapters configured correctly. If you're connected to Wi-Fi and to a router, then it gets a little bit conflicted. And this is the same, but with a Raspberry Pi. In this case, if you would like to change your same algorithm from an Arduino to a Raspberry Pi, all you do is you put the Raspberry Pi block, select Raspberry Pi, and then you're all set for using the same model. Then you click Monitor and Tune, and you can interact with your robot or with your hardware directly, and you can receive information back. Okay, we've already shown you how to install it, how to find it. The only thing that's left for us to show you is how to go ahead and implement this line tracking model. So I will go back to my MATLAB. And if you're ever wondering how to do something in MATLAB, you should start by using the documentation, which is the index, the information of everything that MATLAB can do and all the functions that are available. To open it, you just type doc in MATLAB, and it will open up a browser with the whole documentation. And this is all available online as well, so you can just go to the MATLAB documentation website. And over here in the bottom right now, you'll see the different hardwares libraries that I have installed. So I'll open the one for Lego. And up here, I will go to examples. And you will see a lot of different examples available for programming Legos with Simulink, which is what we showed you today. Um, how to drive robots with PID controllers, how to do line tracking, how to control the robot from a host computer, how to interact with other devices such as a Raspberry Pi, how to use a Pixie camera with it, a lot of different examples. So I'll open up the line tracking one. I'll just click open example. Um, and you will see a sort of more involved model. So this is something that takes a little bit of more time to build. Um, it's more simple than a single motor. In this case, we're using something called subsystems. So you can see that we've named all of these block motors, right motor and left motor, and all of this block on the left sensors, left motor, right motor, and light sensor, and that will be the encoders and the information from the light sensor. If you double click on subsystems, you'll see what's inside. In this case, there's just two of those blocks to control the motors that I showed you before. And on the sensor side, you'll see the encoder blocks and then the color sensor block. And then everything in between, sort of in this area right here, is the algorithm that we've implemented in order to trace or to track the line, which in this case is a couple of mathematical operations and closed loop control. You can, in this case, on the left, we have the desired values of which we want to react to from the color sensor. And you can monitor if you connect to your robot using a scope as well. So I'll just go ahead and upload this to my robot, and we'll show you guys what it looks like when we put something in front of the color sensor. So right now it's generating the code. You can see here in the bottom left that it says generating code templates. And now it started moving and it's trying to escape from me. And I will put something in front. You can see that this wheel right here, the right one, is moving very slowly, while the other one's moving very fast. And if I put my hand in front of it, it will slow down and it will speed up. And it will change directions. Okay, and I'll go ahead and stop that real quick. Okay. So are there any questions on how we program the robot for line tracking? Essentially, we reuse this algorithm that's already provided for you in MATLAB, but it's all set up just like how we show you how to build these models in Simulink. So it's all built up from the same blocks that are basic, like motors, sensors, and logical operations. So if you go inside one of these, you'll see a couple of things like this is just a multiplier, and then a couple of maybe more advanced things like filters. Um, this is just a subtraction. This is an addition and a subtraction right here. And you can just put together, this is an addition and a multiplier. You can put together the blocks to develop whatever algorithm you're looking to implement. I'll take a break right now to see if you guys have any questions. Any questions? Okay.
Then I'll ask question.
They don't
it's
ask many
it's pretty
questions.
it's pretty a basic question. But so can you go back to the screen that you were showing,
Right.
MATLAB or the Simulink? Yeah. So each, I don't remember what the term that you're using. So each block, you open it up and then you see the code inside. How actually can you make the code into that box?
Right. Yeah, that's a great question. They're called subsystems, and you can,
Yeah, thank you.
if I put, for instance, gain blocks, and I just grab a bunch of these and put them all together. So, let's say you put together your algorithm, you just select them all. It's pretty easy, and you right click them. So I just selected them all, right click, and then you get some options here. One of the options you see highlighted down here is create subsystem from selection. You just click that, boom, and then there's a block.
Oh,
That's how you
cool.
make
And
them.
then you
If
just
you,
name it.
yeah, you can, for instance, if you expand them, you'll see what's inside. If you make them small enough, you can't tell. You can change the name, so I'll just say 3 gains. Um, yeah, and then you can also put pictures on top of this box if you really want to, and that's really helpful sometimes. And you can
Right. So,
rename the inputs and the outputs too.
and then depending on what you have inside of the subsystem, the, I don't know how you call it, the connection bit shows up.
Yeah, that's right. That's right.
Okay.
So I'll just do this. If you, for instance, right now it only has one input and one output. If I
Right.
add another output to it, I'll just hook it up to this gain right here, and I go back. So the way you navigate this, by the way, is if up here you can see the sort of how to navigate the models.
Mhm.
So this is going up one level, going back, or you can just go directly between this, what's called the
Mm,
subsystems. And now it has two outputs, right?
I see. All right, cool. Easy.
Yeah.
Thank you. Mhm.
Yeah, these are super useful. And you end up with really clean models like this one, right? Like there's a lot of blocks in here. But when you share it with people, which is one of the reasons it's widely adopted in industry, you can look at one model and pretty much get a good understanding of what's going on. So you can look at this model and say, okay, well, you are starting with some sensors. There's something called a state estimator that's processing some data there. There's a desired velocity and a desired light. And then all of that is being processed into velocity and heading control, line tracking control, and being sent into the motors. Um, and then you can, whatever you're interested in, dive a little bit deeper in. Okay, thanks, Amy. Is there any other questions? Okay. If there is no other questions, then I'll go ahead and go back to the presentation. Um, if you're interested in trying this out, like Amy mentioned, we're a sponsor and a partner, so this software is completely free for anybody participating in RoboCup. And in fact, most universities, if you're part of a university, will already have MATLAB and Simulink, so you can just use it from your institution. But if you need to obtain a license so that you can use it for programming your robots, um, just go to the web page that Amy put in the chat. We'll share it again, or just type in Google MATLAB RoboCup, RoboCup Junior, and you'll get to the website. And there's a button that says complementary software. You just click on that button and fill in the information that's needed. And it has pretty much all the tools that you can need. It has over like 80 different libraries that you can download, that you have access to. So you shouldn't run out of plenty of features to explore. And we provide support as part of the Mathworks student competitions team. We can answer your questions. There's a big community out there called the MATLAB and Simulink Robotics Arena, which a lot of people interested in robotics and obviously using MATLAB and Simulink, they post questions, they post interesting projects. So you're welcome to join that Facebook community and ask your questions there. We also have an email address called roboticsarena@mathworks.com, where you can send your questions and someone from our team will help you use our tools to program your robots. And we have a lot of video tutorials. So if you're wondering how to do this one more time, there should already be a webinar out there showing you how to connect MATLAB and Simulink to a Lego robot, and you can follow that. And you can also check out all of the different informational content that we make. We make videos on more advanced topics like simulations, perception, robot manipulation, walking robots, or even very simple things like programming task scheduled robots, creating odometry algorithms, detecting objects, avoiding objects. There's tons of videos out there. So just go to our Mathworks webpage and search for videos in there. I think that's it. Thank you everybody for attending. I will be here a couple more minutes if you want to ask me any questions. Otherwise, you're welcome to email us later in roboticsarena@mathworks.com.